Okay, so today we're going to be talking about product and quotient rule, but we're going to start talking about in terms of using trig, natural log, and the exponential in what we're doing. Okay, so there's just a couple of examples that we're going to work through just so you can kind of see it in action. All right, now this one right here, one of the biggest missed rules is product rule, because we don't often see this, or we don't actually think about this as a function times a function, but you can tell that this is literally x squared times natural log of x. When two things in mathematics are next to each other like that, that means multiplication. We're so often seeing these types of things that we don't really think about it that way anymore, okay? But that is why we miss it, okay? We don't really think about it as a function times a function, but this is the quadratic times the natural log, okay? So this is product rule. And again, the derivative of u times v is du times v plus u times dv. Okay, so this is my u, this is my v. Okay, so f prime of x is equal to derivative of u, the derivative of x squared, 2x times v, which is the natural log of x, plus x squared times the derivative of v, the derivative of the natural log is 1 over x. Okay? And again, we didn't have anything to rewrite, but we do still have to simplify. So my f prime of x is going to be equal to 2x ln x plus, this would be x squared over x, and x squared divided by x is just x. And that's my derivative. Now, here we go, we have quotient rule. Okay, so this is d over dx of u over v. V times du minus u times dv over v squared. So this is my u, this is my v. We follow the pattern, so we get f prime of x is going to be x plus 2 times the derivative of sine. The derivative of sine is cosine minus sine x times the derivative of x plus 2, which is going to be 1, all over x plus 2 squared. Okay? And of course, we could simplify, we could just multiply the x plus 2, and we get that minus sine x. But since it didn't actually ask us to find the simplification, it just said find the derivative, we are done. That is the derivative. Okay? So now we have a derivative with the exponential in it. So again, I see a root power. I'm going to have to deal with that. I do have 4 times e to the x, but this is a constant, so I don't actually have to do product rule here. Since it's just a constant, this is the constant multiple rule. So the first thing I'm going to do is rewrite f of x to get this into its power form, and that is x to the 2/3 power plus 4e to the x. So the derivative, f prime of x, equals power rule here. So it's 2/3 x, subtract 1, you get negative 1/3, plus 4. Since this is a constant, we can do that and just take the derivative of this function. The derivative of e to the x is e to the x. Now we simplify. So this negative is going to move it to the power. The 1/3 power is the cube root, so you get 2 over 3, and this is the cube root of x plus 4e to the x. And again, e to the x is that awesome derivative that whenever you take the derivative of e to the x, you end up with e to the x. Now this one here, the last one, again, we have a trig derivative, but we don't have product rule or quotient rule going on, but I do have this power in the denominator, so I'm going to have to rewrite first. So, start by rewriting. F of x equals 2x to the negative 2 power plus tangent x. So that's my rewrite. Notice I have not taken the derivative of anything yet. Okay? One of the biggest mistakes students make is when they're rewriting, they take the derivative of another part of it And if you do that and you write f of x equals, that's automatically wrong. Or if I wrote here f prime of x and I'd actually taken the derivative of tangent and wrote it here, that would also automatically be wrong because this is still f of x. Okay, so make sure you're just rewriting and you're doing all your derivatives at the same time. So we do power rule. So negative 2 times 2, which is negative 4x, subtract 1 to the negative 3 power, plus the derivative of tangent is secant squared x. And again, simplify, we get negative 4 over x cubed plus secant squared x. So as you can see, we're starting to add in multiple derivative rules. Okay? It's not just one rule. We tend to use multiple rules in one problem. So make sure you're keeping track of all of your rules.